Welcome to Mr. Patel's IB Sports Exercise Health and Science class, and today we are talking about, nope, not food, it's protein. So, proteins, what do you know? Everybody tells you gotta eat enough protein as a kid. Um, proteins are the second most abundant components in the body. Water is probably the first. And we create these proteins uh, like they're actually we don't create them, but they're created by uh, the formation of amino acids. And if you remember anything about amino acids, those are compounds made of carbon, oxygen, hydrogen, and nitrogen. You have to have those four different elements or compounds. So most amino acids are characterized by the same central structure, and they have a side chain that distinguishes what they look like. We'll see that in just a little bit. But I want to spend a little bit of time first watching a video that talks about specific amino acid compositions. We actually have over 20 amino acids that have been identified as required for the synthesis of proteins or the development of proteins. And of the 20, 8 are essential and need to be provided in the diet. So the essential amino acids can be listed out. So let's watch this little video and feel free to take any notes that you want about the different amino acids. Awesome. So that gives you a pretty good idea of what all the different essential amino acids are and non-essential amino acids. So I know in the video it says that there are 22, and that's all, again, very debatable. We typically say there's 8 essential and 12 non-essentials. And so looking at the structure, let's think back about what a carbohydrate looks like. It's a 1 to 2 to 1 ratio of hydrogen, carbon, and oxygen. Then we saw a triglyceride, where we had a glycerol molecule that kind of took up all this side, and it had 3 fatty acid chains, all made of carbon and hydrogen, and sometimes they were bent because of double bonds, and sometimes they were straight. And then we have amino acids. So we have the amine group, which holds the nitrogen. We have the carboxylic group, which is the carbon component. We have an alpha carbon or a central carbon. And then we have a side chain. Basically, the R indicates another atom or molecular structure of some type that's attached to this central alpha carbon. And this could take the shape of anything. It could be huge, complex, it could be simple, lots of different things here. When we talked about carbohydrates and lipids, we were discussing that we combine them by a process known as a condensation reaction. Well, in proteins or amino acids, we actually have to use a different type of bond. It's still a condensation reaction, but now we create a peptide bond or a peptide link. So that's a kind of a unique thing to think of for amino acids. Furthermore, condensation reactions can link amino acids to either end of the dipeptide chain. So now we call it a polypeptide. Right, so these are peptide bonds, so now we're going to call them polypeptides. And remember, essential means that they're not synthesized in the body and must be ingested. I think we talked about phenylalanine, valine, threonine, tryptophan, which is turkey, right? Isoleucine, methionine, leucine, and lysine. And then, of course, the non-essential are manufactured by the body and can be obtained really, really easily. So proteins, huge source of energy, right? We've talked about 100 grams of carbs, 100 grams of fat. Now let's talk about 100 grams of protein. How much energy does it produce? It actually only produces 1,720 kilojoules. That's not a lot, but again, be careful because the functional activity of proteins is determined by their structure, size, and shape. And proteins have a wide variety of functions in the body. There's really 4 groups. There's the structural group, which is muscles, bones, skin, cells. There's the transport and communication group, which is plasma proteins, hormones, receptors, neurotransmitters. We have a protective component of proteins. That's going to be your antibodies and mucus and anti-inflammatory proteins. Then we have enzymatic, the 4th category, which is digestion, metabolism, pathways, oxygen and CO2 transport, etc. So dietary protein deficiency is a huge thing. We call that protein energy malnutrition, and you've seen that where young children are super malnourished. You don't see it in the Western world. In the Western world, we typically are over-consuming protein because that's kind of our meat is our main source of protein. And typically we can digest animal protein better than we can plant protein. So just something to be thinking about. I want you to just think about what are the factors that influence adequate nutrition? What are the consequences of a lack of carbohydrate, fat, and protein in the diet? And why are children at the greatest risk of suffering from undernutrition or malnutrition? So we'll talk a lot about other components of nutrition here in the next couple of days. And thanks for listening. And I hope you have a wonderful day.